Hi everyone. Hi everyone. So we'll just get started with questions for this week, and just give you a small overview of what was done in this week in the main lectures. And as usual, I assume that you must have seen the lectures. And if you have any questions, you can ask me. Yeah. So let's just get the motions right. So it's been mostly about something about a protocol called TCP, which is for the data center. So if you remember in the last class, we spoke a little bit about the data center architecture and why it is special. It has a very special use case. So the data center is not like the core internet. So some protocols that work well in the core internet will not work. So an example for that is the TCP. So what is TCP? It's transmission control protocol, right? So this does not work well in the data center. So they came up with a new protocol called data center transmission control protocol. This is specifically, oh yeah, hi away. Yeah. So this is specifically used. Oh, you can't see the screen? Okay. Hmm. Rashmi, I don't know if you're able to see the screen. Anyway, I'll share it again. Okay, so probably you can try joining again away. Okay, cool. So yeah, so data center transmission control protocol. Right. So it's nothing but a more glorified version of TCP, which is more specific to the kind of topology that is found in a data center. Right. So similar to how, let's say, an analogy is if we are driving in the city, we drive slowly. But if you're driving in the highway, you drive faster. It's the same car, you're driving faster. So you're modifying some parameters of a particular protocol, and then you are uh, the protocol here, let's say, is driving, and you are applying the same. You're using the same steering wheel, you're using the same car's tires, you're using the same transmission, everything, but you do a different job both in cities and highways. So similarly here, the data center is equivalent to the highway. And oh, I'm sorry, the data center is similar to cities, and the core is equivalent to highway. Right, so data center has some other issues, which because due to congestion, it tends to complicate the performance of congestion control by TCP. So again, I think you must remember what congestion control is by TCP. It's just a mechanism by which TCP detects and adjusts its rate of sending just to make sure that there is no pressure on the buffers in the front so that packets are not lost. Right. So yeah, so this was one aspect that was covered in the videos, and the other aspect was and the other one was I think in network telemetry. Yeah, right. So int, which is in-band network telemetry. This is network. So a brief context about network telemetry. It is that we have these data centers, but in order to find out or diagnose what is happening in a data center, because the data center consists of so many nodes like this, right? So it just keeps going. Just a small sample, right? So this is a data center, and then you have packets that keep going like this. It can go like this. It can go like this. I mean, you have multiple use cases. So you have packets going from n places to n number of other places. So in order to understand more about the network, you need something called telemetry data. So telemetry means data about data. So in this case, you want to know where a particular packet is starting and which are all the switches that it is going to, and what is the destination, let's say. So you need a way in which the actual reason for the packet is not hindered, meaning if a packet is a video streaming packet or YouTube packet, let's say, I'm just keeping it very simple, it needs to do its job, right? It needs to go from point A to point B to get some YouTube data. So that is its primary function. But the data center architecture or the network architecture should also have systems in place where it needs to monitor these packets. Right? And one of the ways in which monitoring can happen is through network telemetry, and that's done through the INT framework. Okay, and that is it about in network telemetry. And right after that, we come to serverless computing. Right, serverless computing. So you must have heard of SaaS, PaaS, IaaS, right? It's something on similar fronts. I'm not going to explain what these are. This is a part of cloud computing, which I think it's pretty much a prevalent and understood term nowadays. So serverless computing kind of decouples the business logic. It decouples the business logic and decomposes the application to functions. So a whole application that you want to deploy is completely cut up into functions, and it is deployed as such. So we don't know what is the platform this function is running on. You just write the code or the high level logic for this function, and then you run it. That's all. It's something. It's as simple as that. You don't worry about what is the backend database that is used to store. Is it using SQL based, or is it using no SQL? You don't worry about all of that. You just say, I need to store A, B, and C. Do it whichever way you want, and you monitor the number of times people want to hit this particular application programming interface, and then bill me accordingly, right? So this is the latest paradigm in cloud computing, I'd say. So um, so yeah, and this was something, and an introduction to this serverless computing was pretty much given. So there are questions based on these three aspects. Let's just dive in right now. So which of the following statements are incorrect about data center TCP? Right, so let's go into it. Let's just take a 2-minute break or 3-minute break, and then let's get into the questions. Right? If you know the answer to the questions, you can put it on the chat. If not, also it's fine. You can just passively listen. That's completely fine. You don't have to respond. Right. So let's get back into it. Which of the following statements are correct or incorrect? Oh, sorry, are incorrect basically. So we need to look at wrong answers about DC-TCP, right? So DC-TCP provides high burst tolerance and low latency for short flows. Now, it is correct because data center. I mean, I think if you've seen the videos, you'd see that data center mostly contains of mice flows. These are also called mice flows, short flows. So if you don't know what a flow is nothing but a set of packets, right? So let's say there are two computers, A, B, C, and then sorry, six computers, D, E, F. Right? If A is communicating to E, then this is flow one. If A is communicating to F, it is flow two. Right? So a flow is characterized by its 5 tuple headers. Again, if any of the words I'm using is not familiar, feel free to message or ask even the basic questions. It's completely fine. All right. Um, yeah. So it's a 5 tuple combination, which tends to make a unique hash out of it. Okay. So DC-TCP is for short flows, and it provides a high burst tolerance. So how does it do it? We discussed this in the last class. Funnily enough, we spoke about the mechanics of it in the last class. So essentially, you use ECN notifications, explicit condition notifications, where you monitor the buffer or the queue size of all the switches. And if the queue gets near full, let's say it's nearing its full capacity, then an ECN notification is sent to the sender to reduce its speed. So where this differs is on the fact that from in regular TCP, you wait for packets to be dropped, right? And then you retransmit. In fact, you push the network to its limit where you drop packets and then you retransmit those packets. That's how you discover the capacity of the network. But here you monitor the queues of the switch buffers, and this is possible because it's all under the same administrative domain. Now I've just spoken about it just in a glancing manner. If you've seen the videos, you should be able to link what I'm saying with what DCTCP is. Right. So this is a correct answer. So which means this is not for this question. For this question, it is wrong. Okay. And so DCTCP can help alleviate loss due to buffer pressure. Yes, buffer pressure is the switch buffer pressure. That is. Okay. This is also not the answer for this particular question. So DCTCP drops packets indiscriminately to reduce network load. So it does not drop packet indiscriminately, right? It has a logic behind it. So this is wrong, which means this is correct for this question. DCTCP uses ECN to signal congestion to sender before packets are even dropped. This is pretty much what I was saying. This is correct, which means for this question, the answer is wrong. The answer is C. Right? So what is the role of the alpha parameter, right? So this is the symbol if you see alpha in the videos. So this is the congestion estimation variable. Right? So basically what it does is it represents the fraction of packets that have encountered congestion. So how does it know the fraction of packets? These are all packets which are marked using the ECN mechanism, which is explicit congestion notification. So the sender sends this value to adjust its congestion window, ensuring smooth rate adaptation. Right. So basically, this alpha is also updated based on the feedback from the network, from the ECN feedback. Right. And of course, this makes it the central aspect to DCTCP's congestion control mechanism. Right. So since from it, I've just told you that it is something that represents the fraction of packets that it encounters um, that are encountered as marked, right? The fraction of packets that are congested. So the answer is B. Okay? This is not the answer. This is not the answer. This is not the answer. Okay. So this is answer is B. So which of the following statements is/are correct about computing models? Again, these are all questions that you would have probably encountered in your bachelor studies. So let's just read through it and then we'll figure it out as we go. Right. So in the platform as a service model, the user manages services such as runtime, middleware, and operating system. Right. Um, Pretty much not, because in a platform as a service model, the cloud provider is supposed to manage it. right? It's not that the user manages it. The problem is user is not managing. So this is wrong. Right? So the second statement is the same statement, but it says cloud. So this is correct. Runtime, middleware, and operating system. So there is a diagram in the videos, if you see. And that diagram clearly explains, I mean, it kind of gives you the demarcation between what all managed in ASPAS and SAS, let's say. Yep. Okay, so in IaaS, in infrastructure as a service model, hmm, the cloud provider manages services such as runtime, middleware, and operating system, or no. So this is also wrong, correct? In IaaS, so this they have nothing to do with these three. And in the serverless computing model, the provider manages the underlying infrastructure such as middleware, operating system, and other related services. So this is correct. This is a direct. You directly clean this off of that particular diagram that has been exposed, right, in one of the videos. So answers are B and B, right? So what is the disadvantage of monolithic architecture, right? Um, so basically, what is a monolithic architecture? I'll just say it in a few sentences. So a monolithic architecture is something which bundles every component into a single unit. So you don't have clear demarcations. So it is basically something that makes it simple to deploy and easy to correct or troubleshoot, but increasing its size, right? Increasing its capacity to handle more load, which is nothing but scaling. It requires you to completely copy and paste this whole complete package, which is which is the top to bottom completely, which is which is not efficient, right? So scaling is a problem there. So again, what is the disadvantage of monolithic architecture? What is the disadvantage? Is it easier to deploy and manage? Yes. So this is not a disadvantage, this is an advantage. So this is wrong for this question. Is it easy to debug? Yes, it is easy to debug. Is it less scalable than other architectures? Yes, it is less scalable than other architectures, and then this is actually a disadvantage. So this is the answer. It is more scalable? No, it is not more scalable. Scalable is what? Scalable means able for it to be able to handle more load, more number of requests per second. So the answer is C. Right? So the following statement is incorrect about microservices architecture. So microservices architecture, I believe uh, you must have understood from the videos, but in case you've not, so you decouple the whole application, right, into microservices. Right? Now let's say the application is a banking application, then this would be login, and this would be send money, and this would be receive money, right? Something like this. So you decouple the, I mean, you cut the application into multiple chunks, and these chunks are self-sustained, self-sustaining in the sense it does not need to communicate with the other modules except in rare situations and rare conditions. So most of the databases that are required for this particular module to run are replicated within this particular module, right? So that kind of makes gives a lot of advantages. Like if you want to handle one aspect of the application, you can just handle that particular aspect, or if you want to update that one particular login functionality, you can update just that without disturbing the other functionalities. right? Like sending money or receiving money. So again, which of the following statement is incorrect about microservices architecture? Individual components should be loosely coupled, allowing for greater flexibility and scalability. So this loosely coupled is what I mean when I said it communicates very rarely with, it has a very rare communication need with other microservices, right? So this is correct. Individual components should be tightly coupled to maximize performance. So this is wrong. There is no tight coupling here, right? So failure of one component does not impact overall service. True. Lower risk of building and upgrading components. True. So the answer is which of the following statements about network processors is not primarily true? Right? So basically, network processors, what are these? These are specialized CPUs for packet processing and memory optimization, right? In the sense, you imagine you're buying a computer, but this computer is more specialized in handling packet related operations, right? So these network processors can be in switches, right? Or maybe in separate boxes called middle boxes, you can say. You have multiple use cases for such kind of network processors. It's a specialized CPU. So which of the following statements about network processors is not primarily true? Um, a processor specifically designed for networking applications. So this is true. So this is not correct for this question. Special memory controllers for moving packet data. Yes, this is true. A hardware device that encrypts and decrypts network traffic. High-speed packet processing capabilities. Okay. So basically, here, if you see, all of these are things that can be done by network processors. But which are of these are not primarily true. So primary functions are this, this, and this. So encryption and decryption are not primary functions. So the answer here is C. Right? So network processors can also encrypt and decrypt, but encryption and decryption are not the primary functions of a network processor. Right? Nowadays, you have accelerators that help you with cryptographic operations. You have it, but in a classical definition, this is the most farthest away from primary. So that's why you have to say this is the answer. So the following statements are correct about software architectures. Microservice architecture is more scalable than a monolithic architecture. Yes, this is true. Right. I mean, this is a no-brainer. Meaning, I don't have to explain anything here at all. It follows from our discussion. Serverless architecture provides complete control over the underlying infrastructure. No, it does not. What does serverless do? It gives you control over particular functions, right? That you write. You just write the business logic code. That's all. So this is not true. Serverless architecture has limited control over the underlying infrastructure. Yes. So this is the converse of the above statement. So this is true. So all of these AWS Lambda, GCP, Google Cloud Platform, and Microsoft Azure are examples of the serverless platform. Yes, they are. So I think in the very last video, you'd have something called something thing about message delivery semantics, right? So what are the three different semantics from that, let me just remind you of it. So there is something called at most once. Write it down. It can be at least once. Third is exactly once. Right. So at most once, what happens is in this approach, these all talks about the sending of messages and receiving of messages. Okay. So in the first approach, the sending of a message or an event from a sender to a receiver, it provides no guarantee that a given message will be delivered. Right. So if you send something from point A to point B, say point A to point B, you have no guarantee that A just sends it and then it says I've done this job, I've done my job. I don't care if the message has reached B. Right. So this is at most once. That's all. You only send it once, and at least once. So it ensures that sending a message guarantees the delivery of message at least once, right? So in the difference here is you make sure that the message reaches. I'm talking about the second one, sorry. That the message reaches the receiver. Okay, and the third one exactly once. So in this approach, the messages are guaranteed to be delivered only once. So the difference, okay, how I can exactly differentiate it is in at most once you send the message and then you forget about it. You don't care if it reaches or not. In at least once, you keep sending until the message receives. Right? And exactly once, you will send it only once, but you will be sure that the message reaches. It's like guaranteed delivery. So these are the three different types. Now, with that, then we can answer this. So, which of the following statement is incorrect about message delivery semantics of serverless architectures? At least once can result in duplicate messages being delivered. True. At least once is what the second one. So this is true, which means this is not for this one. We're looking at incorrect statements. So exactly once delivery semantics ensure that the message cannot be lost or duplicated. True, right? You're only sending it once. At most once provides no guarantee that a given message will be delivered. At most once provides no guarantee that a given message will be delivered. Oh yeah, right. This is number one. So this is also correct. So this is false. Exactly once message delivery semantics is often used in cases where some duplicates or lost messages are tolerable, where some duplicates or lost messages are tolerable. No. So because exactly once means you send it only once, so there are no duplicates and there are no lost messages. So basically, if it is tolerable, why would you go for exactly once? You'll be going for either at most once or at least once, right? So that is why the answer is D. So which of the following statements about in-band network telemetry is incorrect? Uh, so basically, this is basically used for monitoring, right? I kind of explained this in the beginning. So int is a network monitoring framework used for collecting and reporting network status. Yes, this is true. We're talking about incorrect. P4 with int can find how long the packet did queue at each switch. Yes, you can do this with P4. P4 is a programming language with which you can program the way a switch adds extra messages onto a packet, right? It is a framework used to encrypt network traffic. No, this is not correct. So which means it's correct. It is not used to encrypt network traffic at all. Like it is just adding more information on top of these packets. So it uses the PISA framework for telemetry data collection and transport. Yes. So the answer is C. Which of the following statements slash are correct about quick? Right. So quick, I think it was not spoken much about in this thing, but all these answers directly. Quick is designed over UDP with fresh packet formats. Yes, this is true. Quick supports packet format at frame level data. Yes, this is true. Quick receiver can deliver packets to application as long as stream packets received are in order. This is also true. Quick uses the same sequence number for data and packet delivery. No, it has two different sequences. Right? So let's set about quick. Let's skip quick for now. And let's concentrate on this week's. So yeah, the answer is A, B, and C. So what does int stand for in the context of network monitoring? So it stands for in-band network telemetry, right? It's in-band network telemetry. So answer is C. This is very simple. In DCTCP algorithm, what is the role of the alpha parameter? Right? We spoke about the alpha parameter before. So again, what does the alpha parameter do? It is a key parameter that represents the estimated fraction of packets that are encountered during congestion. So these are basically the number of marked packets. So again, what is the answer here? The answer is B. It's a straightforward, direct question, right? So the answer is B. How does DCTCP differ from traditional TCP in terms of congestion processing? So again, DCTCP was something that was improved from TCP, but how does it differ? So does DCTCP estimate the fraction of bytes encountering congestion? Uh, Actually, yes, this is the correct answer. Right? DCTCP detects congestion without using ACN? No, this is wrong. DCTCP doesn't react to congestion signals? No, this is also wrong. It relies slowly on packet loss detection? Nope. This is a very straightforward question if you understand what DCTCP does. So what does it do? It estimates the fraction of bytes that are encountered during congestion, and in the other options are blatantly wrong. So you can easily deduce the answer for this. So the answer is A. So which communication pattern primarily causes the TCP incast phenomenon in the data center? So incast we discovered we discussed this in the last class. So where you have so many nodes like this, right? And suddenly all of these nodes start sending packets, small packets. small mice flows, let's say, to this one particular switch. This puts so much pressure on the buffer of the switch. This is basically the TCP incast problem in data center, and this is mostly observed in the data centers. So what is this? This is many, right? Many are sending to one. Simple enough. So the answer is many to one. So how does the TCP incast phenomenon affect data center network? So this incast, so what does it do? How does it affect it? So basically what it does is it creates a bottleneck at the receiving switch. So this is the receiving switch, this one. Right? It creates a bottleneck at the receiving switch. And what does it do? It causes a buffer overflow and a packet loss. It also causes TCP timeouts as multiple flows back off simultaneously. It also causes the underutilization of network capacity, and it also increases latency as packets are queued at the congestion switch, at this particular receiving switch. So again, it increases data transfer efficiency. No, it decreases. It decreases queuing the delay of flows. No, it increases queuing delay. Right. It increases application level throughput. Nope, it decreases the throughput. Decreases application level throughput and increases queuing delay. So this is correct. Right. This is very simple questions, I believe. I mean, it appears simple to me. So if it doesn't, please let me know. Okay. So what is a microservice architecture? Okay, this is also a very direct question. So is it a large computing network with one code base? Nope, that is called monolithic. A set of independently deployable services with own business logic? Yep, this is the answer. But let's look at the other ones. An architecture based on one code base for simplicity? No, there is no one code base here. It's completely not true. A distributed computing network with centralized code base? No, again, there is no centralized code base. There is a completely distributed system. Right, so the answer is B. So which of the following statements are correct about the int framework? Okay. Int is a network monitoring framework for collecting and reporting network statuses. This is true. P4 with int can find how long a packet queued at each switch. Yes. Int focuses on encrypting sensitive data packets for secure transmission. No, there is no encryption here or decryption. Int provides real-time insights into network performance directly from the network devices. Yes, true. So the answer is A, B, and D. I think this is a repeat question from the previous set. Right. Which of the following statements are correct about serverless computing model? Um, Users manage the virtualization. No, serverless computing, the only thing that users manage are the functions. So this is wrong. So others manage applications. So when I think when they say others here, um, they're talking about the provider. So it is only partially true. So let's just keep it as wrong for now. Both middleware and virtualization are managed by the user. No, this is the opposite, right? The opposite of serverless model. And both middleware and servers are managed by others. So this is actually true. So answer is B. Which of the following are advantages of microservices architecture? Um, which the following are advantages of the microservices architecture, right? So failure of one component does not impact overall service. True. Allow independent deployment of individual features. True. Reduce communication overhead by tightly coupling services together. False. We don't tightly couple, right? So now you know that why this answer is wrong. Scale up and scale down services independently. True. So answer is A, B, and D. So failure of one component does not impact the overall service. That's the whole point of microservices. Allow independent deployment of features. So yes, you can. So instead of login, you can now once you create a login feature, now you can create a logout feature, and these two things will have nothing to do with each other except maybe share the status of each person whether they're logged in or logged out. That's pretty much it, right? Well, that's the BND. Do the following statements are correct or incorrect? Monolithic architecture allows for independent scaling. Um, oh, this is sorry, incorrect, right? So it does not allow for independent scaling. This is wrong. In monolithic architecture, communication between components is faster. So this is true because it is all a single tightly coupled entity. So you don't have to communicate even over the network. It can also be all completely in the same CPU connected by buses, right? So it's not true. So in microservices architecture, so it's just sorry, it's true. So in microservices architecture, all components are tightly coupled. Absolutely not. Serverless architecture abstracts away infrastructure management tasks, reducing operational complexity. This is true. It does abstract because you don't talk. Okay, you just implement your functions. That's all. Right. So answers are A and C. Right. So I believe we've. I mean, the questions this week were a bit. Uh, it was quality was better. I believe it kind of encompassed everything that was taught in the previous week. So if you have any questions regarding this, you can ask me. If you don't have any questions, you're free to leave, and the session is over at this point. All right. So yeah, you can feel free to ask questions or you can leave. It's completely fine. Thank you. Thanks a lot. All right, guys. Thank you.